Now that you have built an introductory understanding on cloud computing, it's time that we try to understand a little bit of DevOps. Let's try to figure out that why suddenly there is so much of hype about DevOps. Why all the software companies, they're trying to accommodate DevOps into their projects. Now let's start from this fact that DevOps stands for Development and Operations. Now before you close this video and you think that okay, I do not know anything about development, I do not know programming, coding and all those things, let me assure you DevOps neither incorporates coding nor programming, nothing like that. You will understand in the due discussion that is going to come forward. Now once again, DevOps stands for Development and Operations. Now I know that doesn't mean much, but that's definitely a point to start with. See, to understand DevOps, we need to first understand how the software industry works, or the software development companies actually work. Companies follow a certain structure while making a software, which is known as the SDLC, standing for Software Delivery Lifecycle or Software Development Lifecycle. In SDLC, we have got certain steps. And it's critical that we understand those steps first before we try to comment on how DevOps is trying to help us out in the SDLC altogether. Step number 1 happens to be getting the requirements from your client. Once you got the requirements, you try to do a feasibility study whether this particular requirement is able to be delivered by your project right now, given the people you have got in your project, or you want to do some new hiring or whatever that comes into picture. Once you find out a project to be feasible, you try to do a design for that. Design can be meaning, let's say, how do you design the user flow? How does the user enter your application? What the things they do and ultimately they get out of your application? The complete idea on what you click, what opens up, how that looks like and all these things. Once that is done, then people try to go for developing the software. The developers come into picture, the programmers. They write their programs, they develop the application. Once it is developed, it moves to the next phase, that is the testing. In testing, we have got the quality analysts who try to compare the actually built application with the originally expected application behavior, if they are the same or not. Simply speaking, they try to figure out whether the application is behaving as per the design completely or not. Once a software is tested and found to be working perfectly fine, it is deployed on the production servers. Deploying on the production server simply means handing over to your client. So now your application is ready to be used by your client. Your client might be people, like we took the example of Netflix while talking about cloud computing. So in case of Netflix, we are the clients, the people who use Netflix. And once a software goes live, that's on production, we try to go into maintenance for the software. Means we try to figure out if something goes wrong, how to fix it immediately to make sure the customer experience is not getting harmed and all those stuffs. Now if you see all these steps, if you try to do manually, it takes you a huge amount of time. In earlier ages, there are situations when one software project will take 3 years to be built. And that was horribly bad. Nowadays, when we have cloud computing, we have so many things with ourselves, when the things are so flexible, so scalable, how do you think even it works out if you take 3 years to build a software application? It doesn't. Therefore, we try to incorporate the DevOps practices to speed up this entire process with the help of certain automation tools. Now before we go into the tools, let's try to understand the process that DevOps tries to bring in. Now it's critical to understand that not everything in an SDLC can be automated. For example, you cannot automate coding. You cannot ask a robot to write a code or a tool to write a code instead of a human. That is impossible. But yes, you can automate testing. You can automate deployment. You can automate the entire maintenance activity. How do we do so? Of course, using tools. Let's see the process once. So developer, let's say, has written the code and the code is ready. That's where DevOps actually starts. After the development is over, developer is required to upload the code in some sort of a repository. What is a repository? A repository is a place where developers can upload the code and the other stakeholders can go and they can have a look at it. We set up an automation tool which keeps on looking at the repository to figure out if there is some new upload happening or not. Once there is a new upload, this tool automatically pulls it. It tries to run a testing activity on top of it. If the testing turns out to be fruitful, which means all the test cases are passed, then it is taken to the next step, which is called deployment. In case the testing fails, this automation tool is capable enough to send an automated email to the developer mentioning the code failure. In case of the positive scenario where the test cases are passing, it is handed over to another group of tools which are known as the deployment tools. Now there are multiple kinds of deployments and therefore you have multiple kinds of deployment tools. I'll talk about the tools shortly. After the deployment is over, following the last step of SDLC, that is maintenance, will also be carried out automatically by DevOps. We'll be incorporating some tools which will be doing an automated monitoring of this application, which means to figure out if something is going wrong, everything is fine or not, and all those things. Once they find out that something is not right, they would immediately notify another set of tools who can in turn go and fix the problem and make sure that the thing is taken care of. And that's how DevOps speeds up the entire process. Let's have a look at the tools that we generally use for implementing DevOps. The repository where the developer has to upload the code, we generally use GitHub for that. GitHub is a very popular and a well-known repository. It is widely used all over the world. The first automation tool that I was talking about, also known as the continuous integration tool, is known as Jenkins. Jenkins is a tool that can monitor the GitHub repository and try to figure out if there is a new upload happening on GitHub. In the official terminology, we call it a push happening on GitHub. If there is a push that has happened on GitHub, Jenkins will immediately pull that into itself. And it will try to incorporate another tool known as Maven for doing the building of that code. Building of the code can be simplified into conversion to binary. Think about this. Computers do not understand human languages. You need to convert it into binary for them to understand. That is one of the activities that takes place in building phase. There are many more which we shall be learning in our subsequent classes. Once the building is over, we take it for testing. And in this testing activity, we shall be taking help of a tool known as Selenium. Jenkins triggers a Maven build, and after that, it triggers a Selenium test. If anywhere between the building or the testing it fails, it will trigger an automated email to the developer mentioning the exact problem. And if both these steps are passing, then it hands it over to something known as Docker. Docker takes care of deployment. Now if you remember, I told that there are multiple kinds of deployments. So we have got multiple kinds of deployment tools. Docker is one of them. Another one is known as Swarm. Another one is known as Kubernetes. Docker is for a single server deployment. That is when you have only one server, you are deploying on top of it. Kubernetes and Swarm is targeted towards clusterized deployment, which means when you have multiple servers together and you form a cluster out of that, you want to deploy on top of it. Docker, Kubernetes, Swarm, these things are also known as continuous deployment tools or CD tools. Next, if you remember, we talked about monitoring for the maintenance activities. For monitoring, we have got a wonderful tool known as Nagios. Now, Nagios is a tool that does application monitoring also, server monitoring also. What does that mean? There is a server on which you have put your application. You have to figure out that server is running or not, because it has to run in order for the application to be served to your client. Also, within the server, the application also should be running. So both your server as well as your application should be running. And Nagios has a wonderful capability to check both of them. Now, in case there is some issues going on, how do you fix it in the maintenance phase? You have got another two tools. You have got a tool called Ansible, coming from a very famous vendor known as Red Hat, who also produces a wonderful version of Linux known as Red Hat Enterprise Linux, which we shall be working on a lot in this entire course. Also, we have another tool known as Terraform. Terraform and Ansible, both these tools are wonderful that help you in building and maintaining a complete infrastructure just from your command line without requiring you to actually log into your remote servers. Now, when you learn all these tools and you know how these tools work and try to make an interaction among all these tools to form a complete end-to-end pipeline, that's when you start implementing DevOps. I told you I'll talk about an example about DevOps as well. Remember today's first example, we talked about Netflix. Now, as a user, you go in and you register or sign in and you go and you get the catalog, you select a movie and you watch the movie. This was the steps for the user. Now, these steps are determined in the design phase and then the coding is done. After the coding is done, DevOps enters the show. Once the developers of Netflix, they have written the code of Netflix, the Netflix application that is running on the server, which is supplying you the movies and taking your username, password, verifying and all those things that is happening over there. That is first tested by using automation tests. Then that is deployed using a continuous deployment tool on the Netflix server, and that is maintained by using this maintenance and monitoring solutions that I just now talked about. And that is how DevOps is implemented in Netflix.